Hey everyone, welcome. Thanks for joining. This is third Friday of our series now. So I'm Jeff Nunn. You're watching Twitch, Alexa, Voice, and Robotics. Today I have a really special guest. This is Nitin Arora. Nitin's from our SDE team, or our Alexa Gadgets team. He's an SDE on that team. So if you tuned in last week, you saw me use the Alexa Gadgets toolkit to kind of start playing around with a color cycler where we hooked up a Raspberry Pi and an LED to make it change colors. Now Nitin's here to show off a cool project he's made, and I really hope it'll inspire the developers out there to do something similar because you're going to use some cool keys and interactions with Alexa. In fact, let me show what that looks like real quick. So this is the keyboard. Let me see, move this out of the way here. Let me see it. Maybe not. Let me get my camera working on that. Let's see, sorry, Nitin.
That's okay.
All right, why don't you tell them a little bit what you're going to do, and I'll
sure.
get the camera working for us.
Hey guys. So yes, thanks Jeff for introducing me. So yes, I'm an engineer in Alexa Gadgets team. So today we are going to demo a project that we made using custom interfaces and Alexa Gadget. It's called a musical keyboard. So it's going to be a kind of a piano, which you're going to get taught by Alexa how to play it. And we are going to show you a quick demo video of how Alexa can teach you how to play Happy Birthday, for example. And it's going to show you, Alexa is going to teach you one sequence at a time, and then give you feedback on are you doing good or not. So that's going to be the gist of our demo. And then once our demo is done, we will go into the code, how we actually took Color Cycler that Jeff showed last week, how we got it up and made a musical keyboard out of it. What were the changes we made in the Python code that we exposed using the Raspberry Pi open source examples that we released, and the custom interfaces.
Yep, and so if you saw me coding last week, you saw me fumble through a lot of things that hopefully it will be a lot clearer now that Nitin's here to show you. So I'm excited to have him show that off.
Yeah, thanks. So I think I just want to talk a little bit about the terminology we'll be using in this the stream. So I know we talked a lot about custom interfaces in the last stream. We talked about Alexa Gadgets and overall the Pi AGT platform that was released. So let's talk about custom interfaces. So I think like you guys are aware, Alexa skills are a way a user can talk to the Alexa cloud and have very voice-driven experiences. So Amazon recently launched custom interfaces, and these interfaces are like the APIs that have been exposed for users to develop experiences through which skills can talk to your gadgets or accessories which are connected to your Echo device. So it's not you all the time that's interacting with Alexa. Your gadgets or your Bluetooth connected accessories can also talk to the cloud. And that's one thing. And when we say custom, that allows the skill developers to add more flexibility into the payloads that they can send between the skill and the gadget.
Good, yeah. So in the documentation, I know there are several like standard ones that come with it, right? So standard directives, but we're really interested in the custom ones. So I'm assuming custom ones will be involved today.
Yeah.
But I'd love to show the developers how they can do that and build their own things with custom directives too.
Right. And again, like your demo last week, right? The color cycler, what Jeff was doing was he was sending a very custom payload which had a sequence of colors that were actually appearing on the Raspberry Pi based platform. And when you press the button, there was a custom message that was going from the Raspberry Pi all the way to the skill, telling which color was there when the button was pressed.
Yep.
So we are basically going to enhance that further, and we are going to use the same Raspberry Pi platform that we used.
Okay, good. So I'm sure I'll have questions as you go through the code, but if the audience has questions too, just pop them over in the right-hand side of your screen on the Twitch comments and chat section, and we'll get to those questions too.
Awesome. Do we want to do the demo?
Maybe do a quick demo of it. That'd be great.
Awesome. So let's see. That's our Alexa device. Stop. And it's right now connected to the keyboard that you see on the screen. Let me open the SSH window that I have, which is plugged into the Raspberry Pi. So the skill's name is MusicBot. Here it goes. Alexa, launch MusicBot.
Hello, let's learn how to play piano. Choose a song. Option 1, Happy Birthday. Option 2, Twinkle Twinkle.
Option 1.
Repeat this sequence. Are you ready?
Yes.
Your turn. Nice. Learn the next pattern.
So I'll repeat the sequence now.
Your turn. Nice. Learn the next pattern. Your turn. Ouch. You missed it. Let me help you
So
there.
I pressed the incorrect
follow
key.
me.
She found it, and now she's trying to help me by going into an easier mode.
Nice.
She's just pressing one LED at a time, so that I don't have to remember the sequence.
So we're seeing debug output on the screen at the same time?
Yeah.
Okay.
Nice. Learn the next pattern.
And sometimes I notice the note is longer when you push it. Is that showing up here too, like the length of time you hold the button?
Right. And I'll explain that there are some delays that I've added, and they can be programmed through the custom
Okay.
interfaces as well. So I think I didn't see the sequence, so let me make a
Yeah,
mistake.
I tried to distract you.
You missed it. Let me help you there.
So that's the last
Just
sequence.
follow me. Amazing. Now you know how to play Happy Birthday.
Right.
That's really cool.
Yeah, so you see there are a couple of modes in this. One is you have to remember the sequence, but if you're not able to remember, Alexa just dives right into that and tries to help you using an easier mode.
Yep. So without going into the code yet, tell me what's happening just at a high level. So like the communications that are happening between the device and Alexa.
Actually, let me open the page that you showed last time as well. Yeah, that's actually a very good overview of what's happening. The Alexa gadget you see here is the Raspberry Pi platform that we are showing. It's the musical keyboard right now.
Okay.
That's our Echo device, and we have a skill code running, which I'll show in some time.
Okay.
So what's happening right now is you launch the skill. The skill gets a message that it has been launched. And again, this is a well-known communication between skill and user. It says, "Hey, I found. Thanks for launching me. Make a choice of song." And then it turns on the microphone, goes back to the user. User again says, "I want option 1. I want to learn Happy Birthday." At that point, when the user says, "I'm ready," the skill sends a custom directive.
Okay.
And the custom directive has a sequence of notes that are going to get manifested on the keyboard. So right now I'm sending a sequence of numbers. For example, for the first sequence, I send a sequence of numbers 112143, which is basically going to light up the keys first,
Okay.
and second, and so on and so forth. So when that message reaches the keyboard, powered through Raspberry Pi, it's going to light up those keys, also play the sounds, and the sounds are locally resting inside the Raspberry Pi.
Okay.
So that way, you, along with the visual indication how to play it, you also get to know how it's going to come out when you are actually pressing the keys.
And so as a Alexa developer, that what they're used to today is building the skill code, right? So there's only a few extra changes that they need to add to that, and then those send the directives across.
Right.
So they're learning maybe just a few new directives to send, but the rest of the skill is just like they're used to.
Right.
Okay.
Yes. And that's, again, the custom directives code. And then the second part is the events when they press the keys.
Yep.
Each key press is actually sending an event or a message all the way to the skill, telling what key was pressed.
Okay.
So that way skill can keep account of what was the order of the keys that user pressed. And like we saw, right, it caught when I pressed the wrong key, and it was able to find out, hey, you pressed the wrong.
Sticking with us during the fun audio issues, but we got it back. Everything's under control. Nitin built a cool robot to fix everything real quick while we were gone. So I hope you stayed around. And Punk Punko, I see your question. I'll get to that in just a second too, but thanks for staying with us. All right, so you probably missed a lot. I'm going to have Nitin start, I don't know, maybe start back. I'm not sure when you guys lost audio, but
Did we get the demo in?
we got the demo in, I think, right? So if you didn't hear him playing Happy Birthday, let us know in the chat.
Okay.
And I'll be looking at chat. But go ahead and tell him a little bit more about this communication again that happens behind the scenes.
So I'll just repeat what I said earlier. This diagram you see on the screen right now, that's basically showing how the communication is happening between the gadget, which is our piano right now, the Echo device, which you see right here, and the skill code that's living in the AWS Lambda. So when you start the skill, there is some basic communication that's happening where you say launch music bot. It's going to launch. Launch the skill. The Lambda is going to get a request, an ASK request, which is going to be launch intent, and then the skill says the regular speech. It sends a speech output saying, "Hey, thanks for launching me. Choose an option 1 or 2." So that's the pre-existing code. Nothing new in that. Once the user selects the song and says, "I'm ready to play," at that time the skill sends a custom directive. And the custom directive has a payload which has a bunch of parameters. The most important one being a series of notes that the piano is supposed to play when it receives it. So for example, for Happy Birthday's first sequence, it has the notes 1, 1, 2, 1, 4, 3. So that's exactly the payload we send, which tells this Raspberry Pi to turn on the LEDs and play the sounds for exactly 1, 1, 2, 1, 4, 3. So you see, this is the first sequence of the Happy Birthday.
And that payload is a JSON payload, right?
Yes.
And then it's a custom payload. So if you wanted to have any type of variable that you wanted there, you could have that.
Right. And exactly, I'm having some more variables. For example, how much the initial delay I want after the Raspberry Pi receives that payload before it actually starts playing, because I want to adjust it based on when Alexa stops talking and when I wants to. And then there is another variable which decides how much gap I have between when the keyboard plays those notes. So there's a bunch of customization going around there. I'll go through that when I go through the code. And then there is one more aspect of it. There is a payload that's also going from the piano all the way to the skill. Those are the custom events which are a part of custom interfaces. And every time there is a keystroke here, there is a custom event that is sent all the way to the skill to tell what node is being pressed.
So we've got 2 JSON payloads going back and forth when you press buttons.
Right. And then the skill can make decisions on whether the sequence of events that came to it were exactly the way it was expecting, or did the customer or the user incorrectly pressed a node, and then it goes into this teaching mode where it says, "Ouch, you did something wrong. Let me help you out there."
Got it. Cool. Well, maybe it's time to look at the code then. I'd love to see that.
So just to go through the setup that I have right now, that's the Raspberry Pi code that's running on the piano gadget. And again, I think Jeff showed the color cycler code. It's pretty similar to that, and I'll go through that. Just going through the setup right now. I have my skill code living inside this Lambda method. It's not too complicated. It's pretty much similar to the color cycler we had. It has a launch intent handling. Other than that, it has custom interfaces handling and sending the custom directives. So. Let's break this problem into, let's say, small parts. So what happens first? You launch the skill. Skill asks you to make some choices between option 1 and option 2, which song you want to learn. And the third portion is when the user says yes, it actually sends the first sequence corresponding to the song that you have selected.
So in this birthday sequence, we've got 4 sequences of notes. So that's the 4 things you stepped through, right?
Exactly. So just going through the code, and just for more understanding or more clarity, I've just added a generic ASK request template here. This is not new. This has been there. The only thing that we added in custom interfaces recently was this type of request. This is basically saying that there is an event received from the gadget.
Are developers able to put that into Lambda's testing sample events, so they could do a test event based off that payload?
It's not available right now. They can't simply test using the events, but again, it might be available in the future.
Got it.
So that's basically where our code flow starts. I'll go through the session attributes in a minute, but let's go from where this whole thing starts. We get a launch intent. Let's see where it is. Yeah, it's right here. So we get the launch request, and then in response to that, we are sending, we're calling this method, and I'll go through this method. This is the most useful method in this Lambda.
Can I interrupt you real quick too? So the one thing I started getting confused on when I did this myself was endpoint ID. So on line 82.
Great.
Can you talk about the endpoint and what that is?
Actually, that's a good question. So along with custom interfaces, we also launched this API called Get Endpoint Enumeration.
Okay.
So when we say endpoint, we are basically trying to find out what all Alexa gadgets are attached to the Echo device on which you're launching the skill.
Okay.
So right now I'm trying to find the identity or identification of my Raspberry Pi, which is doing the gadget job right now,
Okay.
or my piano. And why do I need it? Because when I have to send a custom directive, I need that identification. Like think for an example, you have multiple gadgets connected,
Yep.
and you just want a custom directive to reach one gadget instead. So that's why I need the identifier.
And that endpoint gets created when you pair the device
Exactly.
with the Echo.
When you pair the device or when you get connected,
Okay.
In our databases, there's a field that gets populated that this is the endpoint attached to this Echo device.
Okay.
And when it's connected, so this endpoint enumeration is only going to give you, so this method is going to give you the gadget if it is connected right now.
Okay.
So why I'm calling it every time there is a ASK request, so that I can immediately alert the user if there is no endpoint. I send a message, hey, please connect your endpoint first, because there's no point of learning the piano right now if you don't have a piano connector.
Okay.
So that's basically what's happening. And again, this is similar to what you had in the color cycler. So I won't go deep into the code.
Okay. Yep. Straightforward so far.
Yeah. So we got the launch request. The response is, if you see, I just had a Python dictionary created here. That way it's easy to get the messages and have the code a little bit cleaner. So it's calling the launch request response, and it just says, "Hi, hey, let's learn how to," the text that you heard when we launched this.
Okay. And just I'm going to let the developers know too. We've let them know before, but you can also do this in JavaScript or Node.js too.
True. Yeah, this is just a Python example. I think you had the Python example too, but
And if the developers are watching, if you'd rather see some of these demos in Node, we'll start doing a few in Node as well. So Nitin and I both like Python. We've gotten some demos working with that, but we're happy to do a Node one for you too.
Awesome. So that's straightforward. I just want to go over this function, generate response with session, because I've used this all over this this skill code.
Okay, good.
And this is a generic method which can be used to send any response to ASK.
Any response to ASK. All right.
Like any ASK response. And what ASK response includes when you have to say something, the speech.
Yep.
Or when you have to send custom directives.
Okay.
And the third option is when you have to send a custom interface controller.start event handler. That's an interface very specific to tell our platform that now the skill is ready to accept custom events.
Okay.
So that's basically, again, this is from the ASK documentation. This is how the ASK response looks like. And now we are going to construct it where when I did the launch,
Right.
I'm going to replace this hello with, hey, welcome to this choose a song. So this method has these following attributes. First one is session attributes. As you guys know, session attributes are a way of keeping a state within Lambda, because Lambdas are stateless, right? They don't have a concept. You can't create a global variable somewhere in Lambda. It won't be alive when you get to the next invocation.
Yep.
So session attributes is like, you can also use DynamoDB, but this is like a low hanging fruit. You can easily use session attributes to keep the state. What we are using session attributes is to keep the data, like what song are we trying to train right now? What has been the user's input until this point, so that we know how far he is along the sequence. And there are some other constants in that which I'll go through.
So if you're building a robot and you want to use the session state, it might be a neat place to store like the robot's location, or maybe its last action it did, or its current pose and position. So a good way to use that.
Right. And the third parameter is shouldn't session. That's basically, and this is an old concept. Shouldn't session is used, and this is right here in the ASK response. If you put it as true, your skill ends. If you put shouldn't session as false, it turns on your microphone and it waits for user input at that time. For custom interfaces, when you want to keep your skill alive, but you don't want any other options, like you don't want microphone to open. For example, when we said press the keys, you saw the microphone was not open. She wasn't saying anything.
Right.
So at that time, we added a third possibility. You can just omit this field. The skill will stay alive and it will be waiting for your event.
Interesting. Okay, so it can be true, false, or if you take should in session out, it doesn't observe anything.
Yeah, it doesn't. But it doesn't end the skill as well.
Interesting. Okay, and that's a new feature of Ask, or is it?
It's a new feature. It has been there since Echo Buttons launch as well. They were using the same. So there are display interfaces that use the same method, but I'm just highlighting it because it's not very common for skills to be used.
Good.
So, as I said, right, there's a student session, and then there is a start event handler. That's the fourth parameter, which is telling that I'm ready to accept events right now. Event handler timeout is, if you go through the documentation, it's basically telling that I want events for the next 30 seconds.
Okay.
And if I don't get anything, regardless, give me an expiration on that.
Okay, good.
And the last one is if you want to also send a custom directive along.
Okay.
So let's, and this method is basically constructing this kind of response. So let's go back to our Lambda handler. So right now, if you see in the launch request, right here, it's sending the utterance. Session attributes, they are empty at this point, and it's saying shouldn't session false. So that's why you see the microphone open and it's asking option 1 or option 2.
Okay.
Right? Then you say, for example, you say option 1, or you could have said happy birthday. You'll get a birthday intent, and this has been programmed using the skill development console.
Okay.
Like for example, I've added a birthday intent here, and all these utterances, option 1, happy birthday, and all, they all map to birthday intent. So if I had said happy birthday, I would have gotten the same intent. So I got that, and in response to that, I send another response. Birthday selection. So that's pretty simple one. You got this message. Repeat the sequence. Are you ready? Again, we send the student session as false, which turned on the microphone, and you said yes, right? So now at that point, we got an Amazon yes intent.
Okay.
Right? That's a predefined intent. Now the interesting stuff happens here. We start filling out the session attributes.
Okay.
Because now we know what are we gonna teach the user, right?
Yep.
So we initialize some of the variables. The first variable sequence number is telling we are going to teach the first sequence out of the 4 sequence that we had here. Right?
Okay.
So this is what we are teaching right now. That's what the variable is implying. We put the sequence also in one of the session attributes. It's called sequence target.
Okay.
So this is equal to 112143, right?
Okay.
Total sequence, this is basically putting the length like 4 right now, so that when one sequence gets complete, we have a business logic in the skill that finds out, hey, is the song complete or is it just one sequence? So that's why you're seeing 2 different output responses. One was saying, hey, nice, learn the next sequence, and when the song is complete, she said, amazing, you know how to play happy birthday. So that's why we are using. And this 4th variable is expecting events. So this variable I'm using, for example, when you start playing the song, right, or teaching the song, like this is a very normal human instinct. Everybody wants to press buttons.
Sure. Yep.
And we have seen that in demos before. So this variable is basically telling that as long as this variable is no, just keep ignoring that.
So I can press I can reach over you and mash the buttons. Okay.
Yeah. So only when it is yes, we'll actually start caring and putting our business logic. So that's,
I'm guessing you had to add that later after you figured it out.
Yeah, because we went to a demo and then it didn't work at all because everybody was like very enthusiastic about pressing buttons at that time.
I'd be the same way.
And then at that time, we send a custom directive.
Okay.
With, and this is a method I'll quickly show you. It sends the custom directive with the sequence target, like we mentioned, right? Sequence target was 112143, and there are some more variables with it. So just to quickly show you what we are sending here is this guy.
Okay, so
that's the custom directive we are sending, right?
Custom send directive. We give it a name. We give it a namespace, and I want to see what that namespace in the code too. That's where I get a little confused. Endpoint, I understand. Payload, I understand. Okay.
Right. So endpoint, you got to the enumeration. So payload has 3 options. This is the most important one.
Okay.
This is the initial delay, like I mentioned earlier. This like when the skill, when the piano or the Pi receives that, it's going to wait for 1 second, and then it's going to play.
Okay.
In this example. And then this delay is the gap between the playing of each key. So half a second wait, 1, and then so that you can, for example, for like people who have more difficulty learning, like me, learning the sequences, I can make it slower so that I have more time to remember
that's good. Okay.
So all this business logic is living in the cloud. You don't have to update your device to make these changes. It's all living in the
That's good. Okay. That's a good best practice then.
Right.
Take it out.
You don't need over there updates for updating your
or take it out of the code, the Raspberry Pi code. Okay.
So that's basically what we are sending. This right here is the function that's creating this guy. Right here, it's pretty much the same namespace, and we're just filling up and then sending this through. So let's, we want to look at the Raspberry Pi, how it handles this. Right here. So just a quick overview of this. I think like Jeff mentioned in the last session, we have to add a device secret and type. So I just created a new piano gadget. This is the secret.
So everyone that sees those, are they able to hijack your device?
Yeah, I quickly changed it.
No, yeah, that's good. But if they accidentally leak their code, what should they do if they leak that? If they accidentally leak
its best option is to just create a new gadget. I mean, this is just a reference thing.
It's in the AVS console. Okay,
it's in the AVS. So I have that tab open as well.
Yeah, it'd be good to show them. I didn't show them last week.
That's the basically I've just bookmarked this page.
Okay.
So you go here in the products and then just create a new product. You choose Alexa gadget here. Once you do that, it's going to throw out your device secret and device type.
Perfect. Okay.
And that's the INF file that we showed. That's basically. There's one more thing here. These guys.
Yes.
So that's an interesting thing. For you to receive directives for a specific namespace, and you have to send events for a specific namespace, you have to declare that my gadget owns this capability or declares this capability.
Okay.
So basically it's telling, I'm capable of handling directives which have this namespace.
Yep.
And
this is good because I don't know if you saw the last episode at the end, I was trying to get this Mario cycler to work where it would show these 8-bit Mario images on, and it would not work. All the code looked great, but I did not change anything in my INI file. So I didn't change. I had custom LED cycler instead of custom Mario cycler.
I see.
So I know how to fix it now. So
this
has been a great episode already, just for me.
Oh, that's awesome. And then just for the sake of it, I've also added state listener, and I think you also had the wake word detection.
Yep.
I'm not using it, but every time I say Alexa, you see I can do that right now. Alexa.
Yeah,
so you see,
it's a debug information.
What would you like to play next?
Good.
Stop.
Taylor Swift. Okay. All right. That's really helpful. So if you add custom namespacing and capabilities, you need to add it to your INI file.
Yeah.
Okay.
And then at this point, it's so basically the Python-based library that we have released. It helps you create a gadget very quickly, right?
Okay.
Because there is a lot of stuff that's happening between the communication between the Echo device and the gadget. There's a Bluetooth communication happening. There is a code compression that's happening using protocol buffers. So what this Python library does is it takes away all that complexity so that you don't have to worry about that. All you do is you create this class, and this class is derived from the Alexa gadget class.
Okay.
And the moment you do that, you start getting all these callbacks like state listener that we saw, these kind of callbacks. And for custom directives, all you need to do is add a new method, and I'll show you how we added the new method. So let's take a look at the namespace, or actually the entire so this was our namespace. I'll just paste it.
Okay. And so the method name is not case dependent, right? So
it's actually all small case.
Okay.
So so what this is our namespace.name. So if you have to create a method out of it, let's just put on first.
Yep.
Now it's basically a method taking the string and passing it through a method which converts dots into underscores.
Okay.
And then changes all uppercase letters to lowercase letters.
Perfect.
And
that's good to know too.
Yeah, and that basically helps us create the function.
So you have it nice and readable with camel case in your code, but then behind the scenes, your toolkit goes through and strips out periods, replaces with underscores, and then lower cases.
Right.
Okay.
So we got the callback here with the directive, and and once we do the JSON loads, which is basically converting it's parsing the binary using the UTF-8 encoding and converting it into a JSON object.
Okay.
And when I call JSON loads, payload right now is my Python dictionary object. Yep. And then I can get the various variables that I had set, like the sequence, the delay, and the initial delay.
Okay.
So I got all those values here. I'm also printing them here just for debugging purposes.
Good.
And after that, I call this method process LED sequence, which goes here. And that's a separate file which I'm only using for my Raspberry Pi to interact with the GPIOs and the hardware.
Okay, so you have your main logic here, but then you have another file with all the GPIO.
Right. And then if you see what this guy is doing is it adds the initial delay, sleep for 1 second, whatever initial delay is, and then it goes through the sequence one by one. So it converts the first character into a number, finds which index LED it has to glow, and which index sound that it has to play.
Okay.
And I have an array of or a Python list of the button GPIO. Sorry, in this case, all we need is the LED GPIOs and the tones, and each of this corresponds to a wave file that is residing inside my Raspberry Pi.
And so that's something you did, right? That doesn't come with AGT, the Alexa Gadget toolkit. So you've got a do.mp3 or wave file.
Wave file. Yeah.
Okay, and you're using standard like Raspberry Pi GPIO libraries, right?
Yes.
Nothing out of the ordinary that they'd have to download.
And it's like very basic code. So for example, when I press a button right now, I think this guy is off right now.
And while you're turning that on too, the AGT library, can we show them how to install that too in case
right.
they haven't done that before? Because I know you have a shell script that goes and does dependency checks, things like that.
Right. So let's see. Yeah, that's.
Or they could go to the. Okay, yeah.
Yeah, that's the.
So this is when you go to, if you look at the blog we showed last week, it will lead you to a GitHub repo.
Right.
And there are instructions to clone the repo and then run this setup.
So it's just a shell script. You just run it. It's going to ask you those device types and device secret. And what the good thing it does is it launches, it installs all the libraries. A lot of them are specifically for Bluetooth communication, and it's going to fill up your examples and the INF files with whatever secret and device type.
Good. Okay. Yep. That's great.
So that's pretty much it. And then I was just going to show you how on the piano side, when you get this, how are we detecting the buttons presses and turning on the LEDs? It's very basic code. We have a separate thread which is running a while loop, while true, and every time it iterates through the loop, it goes through all the indexes of the GPIOs and sees whether a button is pressed. If a button gets pressed, basically this check is checking that out. If my new state of my GPIO is 1 and initially it was 0, what I do is I turn on the LED, and then I also play a wave file, which should be right here.
Self-play wave, and that's let me see that method too. That's one I haven't tried before.
So yeah, it's
so Pygame. Okay, so Pygame's library for playing the sound out. Can it take MP3 too, or does it need?
It takes MP3 too.
And then can you go back to the GPIO, the code? So it's scanning, you said it was scanning all your keys. So we're scanning all, so if they had motors and servos and they're looking for actions on those, they're scanning.
And there is an easier way to do that. I think on the color cycler, I believe we are using Pi0 or some GPI0 or some other library which can just give you callbacks. I just did that because I was trying to do it quickly. I just tried to loop. But that's another method you can do.
Okay.
So this is like pretty straightforward. You get a button down and you turn off your LED here.
Okay, that makes sense.
So that's what it is. So we saw how we parse the custom directive.
Yep.
And we saw how what happens when you press the button. There's one more thing I want to show you what happens when you press the button. Or when you get the custom directive. This is the method we were getting. So you play the sounds. This is the method that we showed.
Okay,
plays the sounds. At the end, you send a custom event. And that event has a very, it's not important, the payload, it's just saying that the sequence has stopped playing on the piano now.
Okay.
And this event reaches the skill. I'll just go to the skill code to show you where it parses it. But it is that point where skill says, your turn now. Because now the skill knows that the piano has played.
So it's gone through all of the...
Exactly. It's going through, it's basically a state machine that's, it's following based on the messages from the skill to the gadget and vice versa. So just to quickly show you where that is happening, that's again the same function lambda handler. Now when we got the sequence ended method, this will be filled. So our request type is custom interface controller.interface events received. That's what we checked. Then we parse the name, namespace, and payload. All we care about in this case is the name, because this is what we got, LED sequence ended, and it says your turn now.
Okay.
And it also puts true here. This is the same variable we talked about, which starts the event handler that I am ready to accept events.
I see. Okay.
So then when you press keystrokes, it's getting it.
And then where was should in session? Is that the none right before it?
None.
So we're not passing false, we're passing none.
Yeah.
Okay.
So we're keeping the session on, but we don't want the microphone to open.
Got it.
So that's basically what is
happening.
happening.
And then you set so that 30,000, is that the 30 seconds?
So it's telling that I am expecting events in the next 30 seconds.
Okay.
This time can go up to 90 seconds.
Okay, so there's a cutoff.
There's a cutoff.
Okay.
Yeah. And then I'm not using expiration events here, but what's going to happen is, and I'm not passing them here, but what's happening right now is after 30 seconds, I get a callback from our platform, from the Alexa cloud, that there is an expiration happened for the event handler that you had started. So at that time, let's say user was busy, he went in the kitchen or something.
Yep.
It can say, I don't hear you. It's been 30 seconds. Do you want to try again? And start another event handler at that time. So you can move around the skill flow based on whether the user has inputted it.
Okay, good. So maybe for flying a drone or driving something, if you were getting to that expiration, you can safely lower it or go home.
Exactly. Okay. Yeah, that's a good way to control that. That maybe the user is not paying attention. Maybe let's go to the safe limits right now.
Yep.
Yeah. So that's pretty much it. What we're doing, and then this is the keystroke event. So right now, when you press a button, I get this callback.
Okay.
Again, this is coming from my GPIO code. I showed you this code where I press the button, all that happens. Alongside that, it is also sending a callback to my other class. That's the one. It's callback button pressed. I registered when I created this class.
Okay.
And I get this callback, and at that point, I'm also sending a custom event. Its name is keystroke. I'm using the same namespace everywhere.
Yep.
Different name, keystroke, and I'm sending the actual keystroke that I pressed. So if I press the first button, it's going to send one.
Sends it back to the skill, back to your Lambda function.
Yes, exactly. Yep. It goes back to the Lambda function, and the skill has this small amount of business logic to see, actually starting from here. It takes out what all the user has pressed from the session attributes, appends the new key that he just pressed, and then update the session attributes again.
Okay.
And then it tries to see whether the sequence has completed or not. So how it can do is whatever is in the sequence target, this was 112143, it compares it with what user has entered so far. If it is equal, that means user has completed the sequence, and then we check if the total number of sequence he has completed or she has completed is equal to the total number of sequence we had.
Okay.
Is the song complete? If that's not the case, we just check if the user has entered the current input so far is correct or not. That's basically doing a substring of the total sequence to see the sequence is correct or not, and that's where. And last case is when user presses the wrong input, and that's where when we hear this message out, ouch.
Yeah, good. I like that one.
So that's basically, I think we covered mostly all the code in this Lambda function.
I understand the custom directives so much better now. That was good. So, and I'm going to put you on the spot because I know you're not the developer of the GPIO library, but what would a user do if they wanted to press two buttons at once? Like, you're scanning. Is the scan quickly enough to catch both presses? If you want to play a chord, for example.
Right. So if you see this code right now, I have while loop with a sleep of 0.1 seconds.
So 0.1, okay.
So that's the resolution I have right now.
Yep.
You can reduce that further. And then you'll be able to catch, let's say, two buttons at the same time. And then the worst thing that's going to happen is even right now, when you press two buttons, like the timing is never going to be exactly the same, right? So they will be caught in one sequence.
Yep.
And that's something you can use for like a multiplayer game, for example. Everybody has a button, and they're playing like a buzzer game or something.
Yeah.
And both of them think they entered or pressed the key at the same time, but your program will actually be able to find out who pressed it.
Good.
And somebody will win.
Yeah. So, yeah, it's really cool. We need someone now, one of the developers, to make a guitar version of this. I think it'd be really fun.
Yeah, and again, this can be extended to any of those instruments. I mean, this is a small toy keyboard, but you can have a big keyboard and you can send all those C#. Again, I'm not expert at any of those things, but I've been browsing I browse generally how to play Happy Birthday. It gives me like basic tones.
At this point, if you memorize the numbers now, 1142 or whatever.
I think for Happy Birthday I have.
Yeah.
But I still make mistakes like I made during the demo. That was an honest mistake.
Good. Well, I was trying to distract you too. I wanted to see what happened. So what if they want to copy this or do this exact thing? You already have the blog post up for this, or at least have the video of this. I know. Is there code posted where they can follow along for the keyboard?
I think not the entire code. We can I think consider doing that as well as a part of our PyAGT. But I think there is a blog post that's supposed to come today or Monday, I guess.
Okay. So, if you want to see more of the code, just let us know. We'll work on that so we get the nice packaged up version of it.
Right.
Let me see if we have any questions. Any questions? Let's see. I know there was one early on. I'm glad everyone can hear us now. All right, so a question from Punk Paco. I'd like to do a skill where I use account linking so users can link to their LifeX or Hue account so the skill can control a smart bulb. So account linking where they can control a smart bulb. Do we have capability now to control like a third-party smart bulb through the
we can
AGT?
use AWS IoT, not through AGT.
Okay.
Because like these, so there are two options, right? If you want to make your smart bulb a Alexa gadget accessory, yes, you can do that. Basically, you'll be following the same method. You'll have to implement the protocol that we have in the tech docs or use the Raspberry Pi sample.
Okay.
And you'll be connecting through Bluetooth to the Echo device, and then you can use your skill to actually send some message, for example, turn on my bulb, turn off, blink my bulb, whatever. But if you're not using Alexa gadgets, then I think the other option is you can go through the IoT route and use shadows and whatnot to.
Yep. So if you haven't tried AWS IoT, then you could do that. You could have account linking that's set up, and then you have a database of the users, like the user's ID, and then what devices they have registered, and then change the shadow state. So the shadow says, "Hey, I should be on right now," and the bulb is checking back and says, "Oh, I need to be on." Turns on or turns off.
Right.
Good. Let's see. Any more questions? So far, none. Any last words or last advice for people that get starting? Like, I would love to hear what the biggest hurdle for you. For me, it was custom namespacing, not understanding that I needed the INI file. So when you were first learning this or designing it, what was the biggest hurdle you came across?
I think timing sometimes is important, and when I say timing, there is a long haul of communication that's happening between the gadget and the skill. There are multiple services, and there's an Echo device that goes in. So sometimes, like for me, getting the timings right. When I say timing,
like latency,
latency is one example. And then, for example, if you see the sounds right now are locally coming from the piano, my initial thought was maybe I can use the sounds through the skill itself, send the event, and the event can actually generate the sound all the way from the skill. It just adds to a little bit more latency. It doesn't feel like that great, but having the sounds local also help in this way that you can have a piano playing even without the skill.
Okay.
So that is a little bit amount of thought that I had. I think there was some more hurdle I was having, like I talked about the expecting events no part, right?
Yep.
So I didn't have that logic when I first created it, and it was kind of a mess. So this whole thing, because you'll press the buttons while Alexa is speaking, she'll start taking inputs and she'll be like, no, this is not the correct answer, even before she's actually looking. So session attributes are a good thing to explore for this whole purpose, because you can manage the state. You can actually decide at what time you're actually looking for user inputs.
Okay, good. Yeah, I think most of the developers should have tried session state and tracking before, but if you're not using it, you should definitely use it. It's really handy, and it'll come in handy down the road when you're making more and more complex skills. No more questions. So I'll tell you what's coming up in the next couple of weeks. We started off, you remember in week 1, we started with the robot, the iRobot, the Roomba, basically, that we could control over IP, over the internet. Now we've done a 2-week series on Bluetooth. We're going to go back to the Roomba and either do object tracking or facial tracking. So I'd love to hear your comments on what you'd rather see. And then we are going to show the third method that we introduced in week 1, which is controlling directly on a device. So now we'll have a Raspberry Pi with a microphone built into it and a speaker, so you're communicating directly with your robots instead of going through either Bluetooth or over the internet. So we'll do that. If you have any more questions or need anything else, we are always here on Twitch. You can reach out to us. You can reach out to me on JB Nunn. I'll get you in touch with Nitin if you have questions for him. But we appreciate your time, and thanks for coming. Really appreciate it. Thanks.
Thank you. This was good.
All right. Bye, everyone.